It is impossible to visualize the scale of the universe. There are roughly 2 trillion galaxies. 2 trillion. 2,000 billion galaxies. And each galaxy is, let's say, around the size of the Milky Way. Some are bigger, some are smaller, but the Milky Way has 400 billion stars in it. It takes light over 100,000 years to cross a galaxy, and there are 2 trillion of them in the piece of the universe we can see, and we're very sure that that piece that we can see is a small bit of what may be an infinite universe beyond. We don't know, actually. And I always say, don't get worried about that, because nobody can picture it.
Are we the only inhabitants of the universe? Does intelligent life exist beyond Earth? These questions have intrigued scientists for centuries. In our observable universe, there are around 70 sextillion stars and roughly 10 million billion planets orbiting them. The unimaginable vastness of the cosmos exceeds human understanding. The ideas of either being alone in the universe or it being teeming with life provoke both wonder and fear. While some scientists, like Neil deGrasse Tyson, speculate that there might be hundreds of civilizations in the Milky Way Galaxy alone, Brian Cox, the renowned physicist, suggests the possibility of no intelligent life in the universe. Furthermore, even if it exists, he argues that we will never detect or communicate with it. Why does Brian Cox hold this belief? What leads him to suggest that communicating with extraterrestrial life is an insurmountable challenge? And how big is the universe? Join us as we explore how big our universe is and why Brian Cox believes that we are the only civilization. When we gaze at the vast starry expanse of the night sky, we grasp our own insignificance in the grand scheme. The myriad twinkling stars above silently affirm that our humble abode, Earth, is but a minuscule fragment in what we commonly call the universe. A brief glance at the celestial dome is ample to realize that the universe must exceed our wildest imaginings in size. But can we comprehensively fathom the vastness of the universe through scientific means? This query remains a focal point in cosmological research. It's plausible that this question may forever elude a fully satisfying answer. Nevertheless, this doesn't deter experts from striving to unravel it. Presently, we understand that the universe, as we know it today, came into existence approximately 13.8 billion years ago. The Big Bang, a process delineating the emergence of matter, space, and time from a prior singularity, is deemed the cosmic genesis of our universe. In physical cosmology, the cosmic microwave background radiation assumes a pivotal role in exploring the earliest state of the universe. This radiation, existing in the microwave range, originated during the Big Bang and continues to traverse the vast expanses of the galaxy today. Through diverse measurements examining this radiation and correlating it with various distances, researchers have managed to estimate the age of our universe. This implies that we can currently peer 13.8 billion light-years into space from Earth. To illustrate, envision a spherical drawing with Earth at the center. The rest of this sphere represents the observable region from our blue home planet. In technical terms, the universe within our sight is termed the event horizon. Specifically, the event horizon encompasses objects whose reflected light is barely visible from Earth. Nevertheless, processes occurring beyond this event horizon remain entirely invisible to our human eyes. As we are uncertain about what lies behind the observable universe, determining the overall size of the universe becomes a particularly challenging task. Consider the vastness of the universe. If we ponder the sheer magnitude of the entire cosmos, a crucial fact emerges. Contemporary experts affirm that the universe is in a constant state of expansion. Back at the time of the Big Bang, an object was approximately 13.8 billion light-years distant from Earth. However, owing to the ongoing expansion of space, the separation between this celestial body and our home planet has now extended to 46 billion light-years. This circumstance implies that in the future, objects in the sky not visible to us today will become apparent. Simultaneously, certain celestial bodies will vanish from our star charts due to the universe's expansion. Naturally, during these observations, we place Earth at the center. This choice is dictated by spatial constraints, as we have no alternative but to designate our home planet as the central reference point in our star charts. However, determining the specific location of our blue home planet within the ever-expanding universe remains an unanswerable question. The measurement of the universe. As mentioned earlier, international teams of experts regularly endeavor to fathom the vast dimensions of space. Despite encountering various challenges, researchers employ diverse methods to explore the colossal expanse of the universe. Key research techniques involve specific measurements delving into the radiation of the early universe. Through these radiation patterns, scientists can ascertain various distances and endeavor to quantify the dimensions of the universe. The most ancient light source identified by researchers is situated 92 billion light-years away from Earth. Yet this doesn't necessarily signify it marks the outermost limit of the universe. Determining whether the universe has an endpoint is a more complex puzzle than one might initially assume. Essentially, the farther an object is from our home planet, the longer it takes for the light it reflects to reach Earth. Some galaxy objects are so distant that the light rays they emit require billions of years before becoming visible from Earth. Considering this, countless light rays are still traversing the universe toward us, journeying for billions of years, but yet to arrive. The universe's shape remains an unanswered research question, crucial for sizing up an object. The true configuration of our universe remains elusive. While some scientists propose a self-contained sphere structure, possibly part of a larger multiverse, others argue for a flat, potentially infinite space. Following the first idea, our universe would be a self-contained structure with an eventual endpoint. If our galaxy is indeed finite, it might theoretically be possible to calculate the universe's dimensions with the right data. However, if the universe is infinite, its size becomes an unanswerable point, as infinite objects lack boundary points for mathematical definition. According to NASA, the universe is a flat construct of infinite proportions. Yet, our universe has a finite age and originated approximately 13.8 billion years ago. That's why our exploration is limited to the time period between the Big Bang and today, an unanswerable question. Despite international teams of experts not currently having a definitive grasp on the true size of the universe, they can confidently assert that it is an incredibly vast, potentially infinite structure surpassing all our horizons with its colossal dimensions. The precise investigation of the universe is a task that will span countless generations of experts. Even though we might never fully comprehend the detailed enormity of the universe in our lifetime, this fact doesn't diminish our fascination with the captivating world of distant stars and planets. Brian Cox recently expressed doubt about the chances of human contact with intelligent extraterrestrial civilizations. He raised concerns that scientific and engineering progress might outpace political development, leading to potential disasters. He suggested that advanced extraterrestrial life might have unintentionally caused its own extinction due to this imbalance. Cox's viewpoint aligns with the Fermi paradox. Despite the high probability of extraterrestrial life, there is a lack of evidence or contact with such civilizations. He proposed that the capability of a civilization to self-destruct could hinder its ability to communicate with other star systems. According to him, technologically advanced civilizations capable of self-destruction may require global collaborative solutions to prevent disasters. He emphasized the need for political leaders to adopt an evidence-based approach rather than relying only on ideology. While Brian Cox leans towards the idea of intelligent civilizations facing self-inflicted challenges, he remains open to the possibility of discovering non-intelligent extraterrestrial life forms. Speculating on the potential discovery of microbial life in ocean worlds within and beyond our solar system, he acknowledges that the search for extraterrestrial life may yield interesting results. Now let's explore some interesting hypotheses that explain why we might be the only civilization, or why we will never be able to communicate with any intelligent life beyond Earth. The rare Earth hypothesis posits that Earth's unique conditions, including a stable star, suitable atmosphere, and planetary interactions, may be exceptionally rare, leading to the emergence of complex life. Factors like a large moon and gas giant planets play crucial roles in creating a habitable environment, showing Earth's fortuitous cosmic luck. Moreover, plate tectonics, highlighted in the hypothesis, contribute to Earth's long-term habitability by regulating climate and recycling essential elements. The convergence of fortunate events, such as the evolution of eukaryotic cells, shows the complex environmental factors and evolutionary contingencies that shaped life on our planet. The Great Filter hypothesis introduces significant hurdles in the process of abiogenesis, proposing that certain stages, from non-living matter to intelligent civilizations, act as filters, reducing the likelihood of advanced life. The transition from simple to complex life forms and subsequent stages face potential filters, including catastrophic events and challenges in developing intelligent, technologically advanced species. Earth's advanced civilization might be an exception in a universe where these filters limit the emergence of widespread extraterrestrial civilizations. The galactic quarantine hypothesis suggests that advanced civilizations intentionally avoid contact with emerging societies, implementing a form of self-imposed isolation to prevent unintended consequences. Concerns about sharing advanced knowledge or technology and anticipating potential risks and socio-cultural challenges lead these civilizations to maintain a cosmic quarantine, respecting the natural evolution of less advanced cultures. So, what are your thoughts on this topic? Do you believe that extraterrestrial civilizations exist somewhere in the universe?